Okay, so let's start the session. Hello everyone, I am Vishakha Pandey. I am from IIT Bombay, doing my PhD in third year from electrical engineering. I'm working on antennas, and today I will be um, solving assignment 7, previous year's assignment 7, and we will be discussing around 10 questions from assignment 7 since week 7 is going on. Okay, so let's start the session. Okay, so assignment 7. So the first question here is, a uniform plane wave is traveling along x-axis. Okay, the uniform plane is traveling along x-axis. Which following describes the electric field associated with the wave? Okay, so okay, so the first question here says that a uniform plane wave is traveling along x-axis. Okay, so uh, so a uniform plane wave is traveling along x-axis. Okay, which one of the following describes the electric field? So it is along electric field associated with the wave. Okay, so since the uniform, can someone from you tell me how to solve this one? Hello, hello. I hope I'm audible to you all.
Yes, ma'am, you are audible.
Okay, all right. So can someone from you tell me how to solve this question? Okay, no problem. See, first thing you have to see here is how the how this electromagnetic wave is propagating. Okay, so here the first option here is in y direction. Okay, and it is propagating in z direction. So this one can't, since our electric field, our uniform wave is traveling along z axis, so the electric field will be propagating in x axis, right? So the second option, so first option is wrong. The second option is also wrong, since the electric field is in e direction, but it is propagating in z direction. So this one is wrong as well. The third option here, you can see that the electric field is propagating in x direction. So the third option will be the correct option. Okay, one second. So here for question 1, the direction of propagation of wave is x direction, isn't it? So the electric field associated with the wave will be propagating in x direction. So this will be the correct option. Option C.
Hello, madam.
Yes, go ahead.
Madam, here beta x direction, but before y vector is there. No, y vector
Yes.
only
So
direction, no, madam.
yes, no, but see here, electric field is in y direction. Yes, it is correct that the electric field is in y direction, but you have to see that a uniform plane wave is traveling along x axis. Okay, so if the plane wave is traveling along x, then the associated will be also propagating in x direction. So here its propagation is in x direction. Okay, so this is a kind of a trick. Okay, so here the trick here is that you don't check out, since it will be perpendicular, right? The uniform plane wave, the our wave, the electric field will be perpendicular to the wave, right? So you cannot determine if it is in the y direction or z determine. It won't be easy for you to get if the electric field will be in z direction or y direction. But what you can check out is where it's propagating, where there is a difference, right? So here we have, it is in x direction, since the wave is traveling in x direction, positive x direction. All right.
Yes, ma'am. Clear,
Okay.
ma'am.
Okay. Okay. So let's go to the second question. So the second question is, in a lossless medium for which eta is equals to 60 pi, mu r is equals to 1, and h is equals to minus 0.1 cos omega t minus z in x cap plus 0.5 sin omega t minus z y cap amperes per meter. The value of relative permittivity epsilon r is. Okay. So here our we have been given eta, mu r, and h, and relative permittivity is asked to us. Since eta is given to us, can we how can we solve this question? Can someone from you tell me how can we solve this question? See, here eta is given to us, so think in that terms. How can we get relative permittivity epsilon r?
Madam, neta, which is equal to root of mu by epsilon.
Yes, yes, very good. Yeah, and then we can solve for that. Yes. So here eta is equals to 60 pi and mu r given is 1. So h is given. Now we have to find out epsilon r. So eta is under root mu upon epsilon. So we can expand this mu naught mu r upon epsilon naught epsilon r. Then we know the value of mu naught. We know the value of epsilon naught, isn't it? We know the value of mu naught, epsilon naught under root mu naught epsilon naught will be 120 pi. We both are constants. Our eta will become 120 pi upon under root epsilon r from here. Okay, these are constant. We can find out the value. Only this will be remaining. Right now, we know the value of eta. We will put it and we will get the value of epsilon r.
No, madam.
Okay, it's pretty simple. If you know the formula for eta, you can get the value here. ठीक है, समझ में आ रहा है? बाकी सबकी वैल्यू दे ही रखी है, म्यू आर दे एप्सिलॉन नॉट हमको आता ही है, हम दोनों वैल्यू डालेंगे एंड वी विल बी एबल टू गेट द वैल्यू ऑफ एप्सिलॉन आर. ठीक है. ओके. नाउ so question number 2, sorry, so here what we got, we got 4, so here answer will be 4. Okay. Question number 2, sorry, question number 3. Let's go to question number 3. Question number 3 says, in question number 2 the direction of electric field is. ठीक, हमें एप्सिलॉन आर मिल गया, म्यू आर मिल गया, ईटा पता है, एच पता है, एच की वैल्यू पता है हमें. तो फाइंड आउट इलेक्ट्रिक फील्ड, the direction of electric field. Yes, we can. Let's can someone tell me how to find out the direction for electric field? सोचो. हमको यहाँ पे मैग्नेटिक फील्ड का डायरेक्शन दे रखा है एक्स और वाई के टर्म्स में, तो हम क्या इलेक्ट्रिक फील्ड का कोई तरीका है क्या निकालने का? कैन वी सॉल्व दिस? ओके. इसके लिए हमको एक साइक्लिक कॉम्बिनेशंस मालूम होना चाहिए क्रॉस करने का, कैसे होता है. लेट्स गो एंड ट्राई टू सॉल्व. लेट्स गो टू द सॉल्यूशंस. ओके, सो डायरेक्शन ऑफ इलेक्ट्रिक फील्ड इज आस्क्ड टू अस वंस. राइट, डायरेक्शन ऑफ इलेक्ट्रिक फील्ड पूछा है. एच में डायरेक्शन we have, it's given to us the direction of h, which is in negative x direction and positive y direction. Okay, now the direction of propagation z cap will be k, right? One second. Yeah. Okay, so here cyclic combinations you have to remember. See, one thing is, uh, for just for solving this question you know the solution and you can solve this question, but it's very important for you to remember these cyclic combinations. Even in later part of your engineering, if you remember these cyclic combinations you will be able to solve many other questions as well. uh, if you remember, we have several questions, right? We have several questions where direction of some vector is asked to us, right? And if we know the cyclic combinations, we will be able to solve these type of questions very easily. So try to solve, practice as many questions based on these kind of cyclic combinations, and once you will have practiced enough you will be able to solve this kind of question very easily. See, it's just for a 1 point, right? So if you go through the whole formula and then you try to solve, then you will take a lot of time, and for different kind of competitions, time is very crucial. Okay, so for even for 1 point, if you save 10-20 seconds, that's very good. Okay, let's go. So here k cross, so cyclic combinations are k cross e is magnetic field. If we uh, do cross product between propagation vector and electric field vector, we will get magnetic field, the direction for magnetic field. Similarly, E cross B is equals to K. Uh, it will give the direction for K, and B cross K will give us the direction for E. Okay. So now we know the H, we know the K. All right. Okay. Here. Yeah. Okay. So here, put these values in the cross product. Simple hx, hy, and k. We know hx, we know hx, hy we know, है ना? And h vector is propagating in, see here, z. So the propagation vector is in z cap. Are you understanding this? Our direction of propagation for this magnetic field direction, isn't it? Since here you can see cos omega t minus z, sin omega t minus z in x and y direction. So you will put that k cap, and we got this, the cross product, and we got this. So here we do the cross product, we found out that it has a positive it has a positive coefficient for x cap and positive coefficient for y cap. So our electric field will be in both x and y cap direction. So here it will be option B. Okay, so electric field will be in positive y and positive x direction. Okay. The, one second. Do you have any doubt here? See, it's all, if you remember the cyclic combination, it's all about the cyclic combination. If you are able to solve, if you remember this cyclic combination, it will be very easy to solve. Okay, and also a trick, and the trick is that direction of propagation will be what whatever is it, what the this whatever is there besides omega t minus that term. So the direction of that term will be the direction of propagation. Okay, is there any issue? Okay, let's go ahead then. Hmm. following statements are incorrect about reflection coefficient gamma and transmission coefficient tau? Okay, so which one of the following? So four different kinds of statements are given to us, and it's asked reflection coefficient and the relation between reflection coefficient and transmission coefficient. Okay, so can someone tell me how to solve this question? I'm not asking for the answer, you tell me how to solve this question. Hello. Hello. Okay, no problem. So see, first is reflection coefficient and transmission coefficient. So let's say that we are sending a wave, right? So this wave, some part of this wave into a medium, okay? Some part of this wave will be reflected and some part of it will be transmitted, right? Okay. So we say some part of it has been reflected with the reflection coefficient of gamma, right? And some part has been transmitted, which is tau. Okay, so the total of reflection coefficient plus transmission coefficient will be equals to 1, right? It will both these terms will never be equal to, the coefficients will never be equals to, will never, can be equal to 1, but it can never go above 1, right? Since it's a part of the main wave, so it these both terms cannot go above 1, right? So the first statement which says that 1 plus gamma is equals to tau. So here, even if tau, let's say, is, that is reflection coefficient, even let's say is its minimum, reflection coefficient is minimum, which is 0, even after that tau is equals to 1, right? But this state, and if it goes 0.1, then our transmission coefficient becomes 1.1. That cannot happen, right? So the first statement is wrong. Why? Because our transmission coefficient cannot go above the value 1, and here the statement says 1 plus tau is equals to 1, so that cannot happen. Now let's see option B. So option B says gamma will be in between value 1 to 0. Yes, this reflection coefficient can be in between the value 1, 0 to 1, right? So this is correct. Both gamma and tau are dimensionless and cannot be complex. No, these terms can be complex, right? So this is wrong. Even they are dimensionless, but they can be complex. So this option is wrong. Then says gamma into uh, tau is equals to 1. This statement is also wrong, because let's say that maximum of transmission line tau is equals to 1. Let's say it's 1. So our gamma will become how much? It will become 0, isn't it? So 0 into 1 is equals to 0. So both of these will be always less than 1, reflection coefficient and transmission coefficient. So if both the terms are less than 1, then their product will always be less than 1. So if they have said that gamma into tau will always be less than 1, then it would have been correct. The statement would have been correct, right? But they are saying is equals to 1. So this statement is also wrong. So here D only. C and D. C only. Okay, all of them are incorrect. Yeah.
Hello, madam. B is correct, no,
Yes,
madam.
B is correct. Yes.
That all of them incorrect, how, madam?
Oh, yes, you are right. So none of these basically. D only, C and D. So D is not correct, right? Oh, wait. Uh, the question here. Okay, so it's important to read the question. So which one of the following are incorrect? Okay. About reflection coefficient. Yes. So which of them are incorrect? So D is incorrect. C and D is also incorrect. C is also C only. C and D incorrect. Okay. So which option do I? Which option should I put then? Okay, we will check this out again. Which option to put? But yeah, this is the correct thing. That A, C, and D are incorrect. Okay.
C is C is only dimensionless means that is correct, madam.
Yes. Yes.
Complex is came, no, that's not incorrect.
Yes. Exactly. So it can be complex. Yeah. So C is incorrect. B is sorry, A is also incorrect. C is also incorrect. D is also incorrect. Only option B is correct. So here options are not given to us. So go ahead. I will check it out and I will put it in the description of my video. Which one is the correct option here? Which what here to put? Okay, let's go. I think all the options are wrong here. What you guys suggest?
Madam, your concept is correct, madam.
Mm-hmm.
You told no, the concept is clearly correct.
Huh. Yeah. So here all the options are. We cannot put any option here.
Yes, ma'am.
Yeah.
That
I
the
think.
reflection coefficient value it will come less than one only. I know, madam.
Huh.
VSWR voltage conductive wave ratio
Hmm.
it will come less than one. That B option only correct.
Hmm. Yeah, okay, that's why the value for this question is 0 points. Okay, so probably the someone who made this question didn't form it correctly, and that's why 0 points are awarded for this question. Okay, good. Let's go ahead. Okay, so question number 5. A uniform plane wave propagating in a medium has E is equals to e to the power minus alpha z sine 10 to the power 8t minus beta z y cap volts per meter. If the medium is characterized by epsilon r is equals to 1, mu r is equals to 20 and sigma is equals to 3, the value of attenuation constant alpha in Nepers per meter will be. Okay, so electric field is given to us and it's propagating in a medium. Okay, the medium हाँ we have it's given to us epsilon r mu r और sigma दे रखा है और alpha पूछा है. Okay, so can someone tell me how to solve this question or should I go ahead? Okay, so here from here you can deduce omega, right? Omega here is 10 to the power 8. This is omega, right? Okay, and what else is given to us? It's E naught is given to us, right? E naught is 2. Okay. Uh, okay, let's go and solve this question. Okay, so omega is given to us, E naught is given to us, and sigma is given to us. Epsilon r and mu r are given to us in the question. Now we know that alpha is equals to, this is the formula. It would have been taught to you by your professor as well. If not, you can refer to the book that I have already shared with you. So alpha is equals to omega under root mu e by 2 in brackets, square brackets, under root 1 plus sigma square upon mu square epsilon square minus 1 to the power 1 by 2. Okay, so this is the formula to solve for alpha. Now here see that if we put sigma square upon omega square upon into epsilon square, uh, we get a value something like this to the squared of 3393, which is way above than 1, right? So here we can neglect this and we can neglect this, right? Here adding 1 to this won't have much difference, so we will neglect it. And then for subtraction as well we will neglect this since it is in the square root as well. So overall our value of alpha will become omega under root mu e by 2, right, into multiplied by sigma upon omega square under root to the power 1 by 2. Yeah. So now mu sigma omega by 2. We know all the values. We know the value of mu. We know the value of sigma. We know the value of omega. We'll put it here and we will get the value of alpha. Okay. So, yeah. So, remembering the value of, remembering the formula. Okay. So, this formula you have to remember while solving the question. Another thing that you have to analyze by yourself, and it will you will get to know after solving many questions, is how to ignore the how to assume. Okay. See here, 3393 is way above, squared is way above than 1, but some of the students, what they do is starts calculating everything. So what they will do is they will calculate this and then add to this and then square root this. So what happens is they take a lot of time to do that. So you have to you have to, that's more of a, it's not about your knowledge or intellect, how much intelligent you are. It's more about the practice, how much practice you have done. So you have to understand where you have to start ignoring the small values. Okay. And this you can say it's a technique of approximation. So if you know how when you have to ignore one from here, then you will be you will take very less time, amount of time to solve this kind of question. Okay. So that's what you have to do here. Let's go to question number 6. Hmm. Is there any doubt?
Clear, madam.
Clear, right? Okay, let's go ahead. A uniform plane wave in air with E is equals to 8 cos omega t minus 4x minus 3z y cap volts per meter is incident on a dielectric slab z greater than 0, with mu r is equals to 1, epsilon r is equals to 2.5, and the angle of incidence is, so angle of incidence is asked to us, and uniform plane wave is given, it's given, the electric field is given to us for a uniform plane wave. Okay. And it's given that it is incident on a dielectric slab where for z greater than 0. Okay. An angle of incident is asked to us. Okay. So something like this. So dielectric material is given to us for z greater than 0. Here a dielectric material starts. So how our n1 is air. Okay. n1 is equals to 1, right, and n2 will be something given to us. Not right now, it's not given to us, it's not required here. Okay. For z greater than 0, and electric field is incident with some angle on a this dielectric slab. Okay. And some part of it will be reflected, right, and some part of it will be transmitted with angle theta t for transmission angle, and reflected angle will be theta. So here theta 1 will be equals to theta, right, incident angle is equals to reflected angle, isn't it? Okay. So our incident electric field is given as 8 cos omega t minus 4x minus 3z. Hmm? We can write for for direction of propagation, we can write it as 4, instead of writing 4x minus 3z, we can write it as ki vector dot r vector. So ki dot r is here 4x plus 3z, right? And r vector here is x cap, y cap, z cap. Hmm? Direction of propagation here, propagation vector here is 4x plus 3z. Putting everything, ki will be equals to ki cos theta 1 or theta I. So cos theta 1 will be 4x plus 3z, right? So also will be 5, right? Can you find out this angle? Can you find out this angle? Yeah. Okay. So cos theta 1 will be plus 3 upon 5. So theta 1 will be, put cos this side, and theta 1 will be 53.13 angle. Okay. It's all because of the direction of propagation. If we know the direction of propagation, we know the ki, right? Ki dot r, we know ki. We'll put all these values and we will get theta 1. Is there any problem you have? Any doubt?
Madam, why you are taking cos theta, madam? Cos theta I. Direction of propagation, cos theta I.
Yes, yes. Direction of propagation. So here see, z is 4, right? And this is x, right? So this angle will
Okay,
be,
madam.
got it? This angle will be, we can write it, right? Cos theta, we can write it right here. Cos theta is equals to 3 upon 5, right? Theta 1. Hmm? Got it?
Okay, madam.
Okay. Is there any doubt you have? Anyone else? Anyone else have any doubt? Okay, then I will go ahead. Hmm. In question number 6, the reflected electric field is, okay. So, can someone tell me why they have not asked reflected angle of reflection? Okay, no worries. See, it's not asked because क्यों नहीं पूछा है, क्योंकि एंगल ऑफ रिफ्लेक्शन और एंगल ऑफ इंसिडेंट सेम होगा, है ना? इट्स सिंपल ऑप्टिक्स लॉ, राइट? तो एंगल ऑफ इंसिडेंस, एंगल ऑफ रिफ्लेक्शन सेम होगा, तो दे हैव नॉट आस्क्ड to us. What they have asked is reflected electric field. So angle will be same, right? Now let's go and see how to solve it. Ah, so here n1, since it's air, n1 is given as 1, right? And n2 is given as uh, under root epsilon r, that which will be equals to root 2.5. Here in the question above it was given to us, right? So using Snell's law, sine theta 1 upon sine theta 2, it will be equals to n2. Sine theta, we will shift n1 here and we will get the value of theta 2, which will be equals to sine inverse 4 upon 5 n2. Now let's find out the amplitude of the reflected wave. So the formula to get an amplitude of reflected wave will be E naught R upon E naught I is equals to N1 cos theta 1 minus N2 cos theta 2 upon N1 cos theta 1 plus N2 cos theta 2. Okay, we will put the values. N1 we know, cos theta 1 we know, cos theta 2 we know. We'll put all these values and we will get this. ठीक, आउट है यहाँ तक में, आगे बढ़ो. The formula that we have to use. अच्छा, तो epsilon naught r will be equals to, it will be equals to minus itna into EOI. So it will be equals to EOR is equals to sorry, E naught R is equals to minus 3.12, since our E naught I was 8. Now the reflected wave. Now let's see the, now the reflected wave will be in uh, in opposite direction to this one in z direction, right? Our reflected wave is in opposite direction, similar to ei, but it has a opposite direction in z, right? The z direction is opposite, so here it will be plus the propagation angle. So that's what is happening here. Here kr is equals to minus 4 plus 4x minus 3z. It's reflected in z direction, right? So that will be negative. So our er will be, we have found out the amplitude, we know the direction of propagation, we'll put it and we will get this value. ठीक है? समझ में आया ना? पहले हमने स्नेल्स लॉ लगाया थीटा 2 निकालने के लिए, फिर जब थीटा 2 आ गया तो हमने ये वाला फॉर्मूला लगाया अपना ई नॉट आर अपॉन ई नॉट आई निकालने के लिए, n1 cos थीटा 1 ये सब कुछ पता था हमें, वो डाला हमने एंड वी गॉट दिस. ठीक है? एनी डाउट? minus 3.124, yeah, something plus 3z. So option here is option B. This one is the correct option, right? Is there any problem or should I go ahead? Okay. Okay, ठीक है. कोई कुछ पूछ नहीं रहा तो मैं आगे बढ़ती हूँ फिर. ठीक. So in question number 6, the transmitted magnetic field is okay. So now see, they have asked us incident angle. They asked reflected electric field. So can someone tell me कि ट्रांसमिटेड मैग्नेटिक फील्ड को निकालने के लिए हम सबसे पहला स्टेप क्या लेने वाले हैं? अरे बाबा, सबसे पहला स्टेप होगा ना ट्रांसमिटेड इलेक्ट्रिक फील्ड निकालना. पहले अगर एक बार हमें ट्रांसमिटेड इलेक्ट्रिक फील्ड मिल जाता है देन इट विल बी वेरी इजी फॉर अस टू सॉल्व, राइट? सो वी विल गो अहेड. पहले हम ट्रांसमिटेड इलेक्ट्रिक फील्ड निकालते हैं, राइट? तो हाँ, वी कैन राइट cos omega t minus kt dot r y cap moles per meter, right? So first, for finding out this, we have to find out the magnitude for kt. So the uh, formula for this propagation, magnitude of propagation constant will be equals to n2 upon n1 ki, refractive index of medium 2 upon refractive index of medium 1 into ki. So we know ki, right? We know n2 upon n1, that is equals to under root epsilon r. We know ki, and we will find out the value of this, which will be equals to 7.90. Okay. Now now we have found out the magnitude for kt. So once एक बार kt आ गया तो हाँ kt मिल गया, right? यहाँ पे मिल गया, हाँ, डायरेक्शन प्रोपोगेशन kt मिल गया हमें. तो वो थीटा 1 थीटा 2 ऑलरेडी पता, x डायरेक्शन एंड kt इन z, तो ही किया है यहाँ पे, has been done. So kt for x direction will be kt sin theta t, or kt in z direction will be kt cos theta 2, which is equals to 6.819. So whole kt vector will be equals to 4x cap plus 6.819 z cap. Okay, is there any doubt till here? Okay, no doubt. Okay, you guys are understanding, right? One second. Even the smallest doubt you ask me. Like Arun Raj is asking me questions, but I see that other students are not asking questions from me. So is it possible that समझ ही नहीं आ रहा? कुछ भी, या क्या प्रॉब्लम है, अगर कोई प्रॉब्लम है तो मुझे बताओ, छोटा से छोटा डाउट भी हो ना तो यू आस्क मी। तो अभी तक तो फॉर्मूला था छोटा छोटा, या पाइथागोरस थ्योरम का सिंपल, स्नेल्स लॉ, ये सारी चीजें हैं। तो आई होप कि वो समझ में आ रहा होगा। और कोई भी इशू हो ना छोटा से छोटा, यू आस्क मी, ठीक है। आगे बढ़ते हैं। यस, हाँ, so we found out the K2, right? We will put K2 here, like sorry, KT. We found out KT. Here we will put KT. Huh? Now we have to find out E naught T. Only if you see here in the transmitted electric field, only two values are unknown to us, right? E naught T and KT. So we found out KT first, and then we will find out the value of E naught T. So value of E naught T will, how can we find out? By this formula: E naught T upon E naught I is equals to 2 dot n1 cos theta 1 upon n1 cos theta 1 plus n2 cos theta 2. Okay, we'll put all the values. We got 0. Multiply it here, we'll send it here, and we will get E naught T. E naught T will be equals to 4.88. So we'll put it here, E naught T, KT, and we'll get this, right? So here first we found out transmitted electric field. Now we have to find out the transmitted magnetic field. But to find out the transmitted magnetic field, B vector is equals to, magnetic field B vector is equals to 1 upon V. Here V is wave velocity dot K into I. K cross I. Sorry. sorry. K cross E. K vector cross E vector. So for transmitted magnetic field also we can write the same thing, KT cross ET, and instead of writing 1 upon wave velocity, we have another formula which is equals to 1 upon V is equals to under root mu E, right? Magnetic field HT will be equals to 1 upon mu BT. So we will put it here, we will divide it by mu, and we will get something like under root epsilon upon mu KT cross ET, right? We'll put all the values. We know KT, we know ET, we know epsilon R, we know epsilon naught, we know mu naught. We will put all these values and we will get HT. Okay. So answer here will be, all of them look same. So hard to, these two, some from this two. Option B and D look same to me. Can someone tell me what is the difference here? हेलो, कोई ध्यान दे रहा है मेरी क्लासेस पे?
Z vector and Y vector is there. For minus B, minus 17.69 X vector plus 10.37 Z vector is there.
Okay.
But D here Y vector, Z and Y vector.
हाँ, got it. So the magnitude is different. Okay. So here X and Z cap. Okay. So option B will be the correct one. Thank you, Arun. और कोई डाउट किसी को? One is for 2 points. Is there any other way to solve this question? I can think of elimination method. So we can first thing that we can do is we can find out the propagation vector kt, right? And if we find out the propagation vector kt first, we will be able to eliminate some of these terms, right? And then we have to find out h naught t. For that we have to do that cross multiplication, cross product. Cool. So first, if we eliminate some of these, so yeah, that is how we can. Another method can be solving it using elimination method. So try to find out the value of kt, and if we get the value of kt, we will be able to solve this one, right? Solve this.
Madam, that eighth problem is very somewhat difficult, madam. Once again,
Hmm.
repeat.
I agree with you.
Yes, that is very difficult, madam. But you are telling, that theory concept also.
Hmm.
I am hearing this is a new thing. That is, it is this concept is coming from reflection and reflection of plane waves only, madam. This all the.
Yes, yes. Yeah.
But I studied, but this you are solving, no. But this solving, but theory concept it is very very difficult, madam. That's what.
Yes. I can understand it's a tough thing.
But it's
But if you really see now, yeah, in gate question also, if you go for gate exam, right? So here, if you see there, for this one concept, right? For different mediums, if we have a plane wave, right? For different medium, if you understand this concept, right, you have around 6 marks, 6 marks total, right?
But that sixth is okay, madam. Up to sixth okay. This seven also I can understand. The electric field how to find out. That the magnetic field is there, no, madam. This one only very difficult, madam. If you, I know that theory concept also somewhat difficult, madam. This only one problem. Remaining thing and all I understood.
Hmm.
That the eighth problem only somewhat difficult.
Hmm. Yeah, so you have to like go deeper into it. So first thing is this, right? If even if you don't go for 1 upon v, if you get to know k cross e, you will be able to get b by the cyclic combination that I told you. So even if you see, even
Why we are multiplying velocity, madam? V which is equal to k cross E we known. That V 1 by V.
yeah, because
V
it's in
which
a
is equal
medium, right?
to
See here, it's not in a free space. It the magnetic field is in a medium, so we have to multiply it with a velocity, wave velocity of that medium. We cannot directly multiply. We cannot directly say k cross e, right? Because k cross e is for free space. We have to multiply it in with we have to, the formula changes, right, if we go in a medium instead of the free space. So that's what is happening here.
Ma'am, ma'am,
Mm-hmm.
hello, ma'am.
Yes.
Ma'am, for free space, we have to multiply it with 1 by v. Yeah? On,
For free space, but for free space, if you multiply, then v becomes, how much v becomes?
uh, the formula is 1 upon v into kt. That is the formula for magnetic field.
Yes, yes. So can you tell me for a free space the value of v, how much the, where is the wave velocity there in a free space?
3 into 10 power 8, no,
Yes,
madam.
yes, good.
3 into 10 power 8.
Yeah, so
Yes,
speed of
ma'am.
light. So
Speed of light and the electromagnetic wave both the same speed.
yes, yes, exactly. So that's what I'm saying. So you here it's v instead of c or something else, because here we are calculating a magnetic field not in a free space. Here we have a magnetic field in a medium, so we cannot directly be what to say, casual about it. We have to check uh, the wave velocity of that medium as well. So that's what is happening here. That's why this term is coming. We cannot be casual about it. We cannot just say, like, even see the refractive index for one, right? So we just go ahead and do that. But here we cannot be casual about the medium, because it's not free space, it has a medium, so we have to divide it by the wave velocity, right? It's not simple k cross e.
Okay, ma'am.
Okay. So what was your doubt, Arun?
Okay, madam. Now clear, madam. Thank you, madam. Now it is clear, madam.
Huh. So yeah, so okay, cool.
The muer value is 1, madam.
Hmm.
The substituting, muer value is 1. Epsilon r by epsilon naught.
It's given in the
Okay, okay,
question.
madam.
Okay.
Hmm.
Okay, yeah. Let's go to question number 9. So in question number 9, in a non-magnetic medium, E is equals to 4 sine 2 pi cross 10 minus 0.8 x z cap volts per meter, the time average power carried by the wave, right? So here 2 pi cross n is omega t, right? 0.8 is what? K, right? Our direction of propagation is x. 4 is E naught. Carried by the wave is asked to us. So average power carried by the wave is asked. So can someone tell me how to solve this one?
Madam, pointing vector, I don't know exactly, but
Hmm. Hmm.
P which is equal to E cross
Madam, P
H.
equal to E cross H.
Yes. Yes. Good.
Hello, ma'am. E naught E naught H naught by 2, ma'am.
E naught H naught by 2.
By 2. Average power.
Yeah. No, but H naught is not given to us, right? So how will you solve without?
E naught is given, na, ma'am.
Yes. E naught.
So H naught is equal to neta into E naught.
Hello. Someone.
Yes,
Okay.
yes, ma'am.
Okay.
Yeah, neta nut value is approximately 377.
Hmm. Hmm. But no. So we are not.
We just
Yeah, so we are not, since the medium is non-magnetic, right? Here the medium is non-magnetic given to us. Okay, so okay, I will tell you. Don't, so mu will be mu naught, right? Here, since it's a non-magnetic, so mu is equals to mu naught. Now time average power carried by the wave will be, it is wave velocity epsilon naught e naught square by 2. Okay, so this is the formula. So the wave velocity here becomes 1 upon under root mu e. Okay. Oh, sorry.
Only velocity, only 1 by root
Yes,
mu
yes.
epsilon.
Only velocity. Okay, and right. And here, 1 second.
ma'am, I have the one doubt, ma'am.
Yeah. Go ahead.
Ma'am, velocity is equal basically under root of velocity is equal to 1 by under root of mu naught into epsilon naught. Again, we just multiply with the under root of 1 epsilon naught into e naught square by 2 into under root of epsilon naught into mu naught, madam. Again, under root of epsilon naught will get cancelled. Again, now we get the neta naught, na, ma'am.
Yes.
So we generally write the value is 377 into
Huh.
e naught square by 2.
Yes, very good. Yes, we can do that as well. Yes. So who am I talking to? Narendra. Yes. Good.
Yes, ma'am.
So we can do that as well. Yeah.
Yes, ma'am.
Okay, 1 second. Huh. Yes. So we can do that. So eta is equals to. So we can do that as well. Yes. Anyways, time average power, we can directly come to here. We know the formula, we know eta naught, we will put, we know this. Eta naught is simple, mu naught upon epsilon naught, we know that, right? We have got it here. In which question we have got? In some question that we solved back, right? So 1 second. Yeah, here we got, right? So eta here we got as 120 pi upon root epsilon r. So we will use this one. All others are constant. So that we got, right? And this is refractive index. This is n. Sorry, eta. This is n. So n is equals to c by v, right? Refractive index is equals to speed of light upon wave velocity, which will be equals
Velocity.
to which will be equals to under root epsilon r. So we will put these values, right? And root epsilon r is pi by 12. Okay, so we'll put it here. We know epsilon, we know e naught, we know under root epsilon r value. We'll put it here and we'll get 81x cap. Cool. Is there any issue you have here in this question? Simple manipulation of these laws, these formulas. Okay, simple mathematics is there. You can easily solve it if you know this thing, right? Or the one Narendra was telling, this thing, this formula. Okay.
Yes, ma'am.
Cool. चलो आगे चलते हैं. So option A. Okay, let's go ahead. In question number 9, the total power crossing 100 centimeters square of plane 2x plus y is equals to 5 in micro watts will be. Okay, so अभी सिंपल हमें टाइम एवरेज पावर था, है ना? अभी उसको अगर वो एक 100 सेंटीमीटर क्रॉस कर रहा होगा, 100 सेंटीमीटर 10 राइट, 100 सेंटीमीटर स्क्वायर को अगर वो क्रॉस कर रहा होगा इन प्लेन 2x plus y, तो उसकी वैल्यू क्या होगी? दिस इज व्हाट हैज बीन आस्क्ड टू अस. सो कैन समवन टेल मी हाउ टू फाइंड आउट टोटल पावर? First thing you have to see is the power is in x direction, right? So now can someone tell me how to solve this one? Okay, no problem. So plane is given to us as 2x plus y is equals to 5. Now normal to this plane will be x, this is n cap. N cap is equals to 2x plus 5 upon under root 2x plus y upon under root 5, right? Now power per unit area crossing the plane, crossing, sorry, yeah, crossing the plane is equals to p into p dot n cap, normal to the plane vector n cap into the p cap. So we know already the value of p, that is 81 x cap. So only what direction will be left for the power per unit area will be in x direction, right? So here the other y cap will be, if we do the dot product of this p vector into the n cap will be equal, this for the y direction it will be 0, right? This will be 0 and this will be 81.2 upon root 5, है ना? So total power crossing area A will be equals to P dot N into A, right? P total will be this value multiplied by 100, which will be equals to 724.5 microwatts. Is there any doubt you have here? No? Okay. All right. So Anyone else? Okay, no question. Then all the best for assignment 7, and I hope that you will be able to solve the questions and achieve really good marks in the question in the assignment. Okay, all the best. And even if you don't get good marks, it's all right. It's you perform better
Thank you.
next
Thank
time.
you.
Cool. Chalo, bye bye.
Thank you, ma'am.
All the best.
Madam,
Huh.
madam, the videos you have to upload within tomorrow afternoon, madam. Why? Because last
Huh.
two assignments you are very late, madam. After the Wednesday only you are uploading.
Yes, right.
Tomorrow afternoon means tomorrow evening it is very easy to solve these questions, madam. In tomorrow afternoon will evening within evening 4 o'clock.
Okay, I will try to do that. See, I couldn't do that because in my previous video, if you see, the audio is not there, my audio is not there. It's because I somehow didn't record my video. My audio I couldn't record. All your questions are there, but my audio is not there. So there are some technical glitches that I face since I'm locally recording my screen and then having the live session. So due to some technical glitches, I couldn't upload the video on time. Okay, sorry for that. Really sorry.
Madam, this solution part is there now
It's okay.
today
It's okay, ma'am.
solution.
Thank you, ma'am.
Yeah, solution.
Today that you put it in Google Drive, madam. That is okay,
Okay,
madam.
ठीक है. I will try to put it in the Google Drive.
At that same link only, na, madam. Already I have that link. One day you said that link you have to post today. That solution only, madam. That is enough.
हाँ, ठीक है. I will do that. Okay, I will upload the solutions in the video and then in that drive, and that will be easy for you, right? ठीक है, मैं वो करती हूँ. Okay, चलो, all the best. Bye bye.
Thank you, ma'am. Thank you.